Thank you for joining us here today at castlepyro.com. I'm going to walk you through our guide on how to make a 36Q panel style firing system out of mostly off-the-shelf parts. This is what the system looks like when it's completed. With just a few accessories, you have a stylus that plugs into it to fire off your cues. You have adapters to connect to your external power source, whether it be a battery or some form of power adapter. You have a on-off key or an arming key, give you a little bit of extra safety. And you have the actual cues themselves. This is a indicator light to let you know when the system is hot or ready to fire. And here are the connections for your Cat5 cables for each bank of cues. So you have 6 banks, and each bank has 6 cues in it. Gives you a total of 36 cues to fire. First thing I'm going to do is I'm going to actually cut out the backing board used for the firing panel itself. This is a printout of the template at the end of the document that we offer on our website. If this does not print out to the correct size, you could test this by taking the printout and cutting it out and actually testing that against your box if you're going to use one of the seahorse case boxes to see if it fits properly and the holes are all aligned. If this does not print out properly for you, there's also a JPEG of this actual template on our website. You could download it, open it up, and print it out to see if it fits. So what I'll start with is I'll start by taking regular clipboard from Office Supply Store. And I'll take my template and I'm going to tape it to the clipboard. I like to tape it to one corner so that I have 2 of my edges already cut out for me. Now with the template taped down to the backing board, I'm going to use a hand jigsaw to cut the template out. Just making these 2 cuts here and here. You don't have to use this exact same template. You don't have to make it the same size. This is only if you're going to use the particular case that we've used for this project, which is a Seahorse brand case. They work very well for this project. They're airtight and watertight. They're pretty rugged and they last a long time. They will help to keep your firing system safe in the rain and from humidity when they're being stored in between shows. And I like them myself, but you could really use anything. If you want to save some money on this, you could make this whole thing out of plywood and make it to any size that you want. You could make more cues if you'd like as well, or less, whatever works for you. This is just an example to help get the ideas started for you. Alright, so let me cut out these 2 lines next. Okay, and this is the panel fully cut out. You want to go a little bit outside of the lines. You could always use a touch of sandpaper if it doesn't fit properly inside of your case. You could always take some extra off. It's a little difficult to add some on, so I like to go a little bit outside my cut lines. And the next step is going to be to start drilling our holes for all of our different components. I use a 1/8 inch drill bit to start. Okay, and with that 1/8 inch drill bit, I'm going to start off by making the 2 holes for my Cat5 connector plate, or wall plate, or switch plate. I like to make my first hole, then I like to line up my Cat5 plate to the hole, to the first hole. And once I get it lined up properly, I use the plate as my template to drill the second hole. Okay, and after those are both drilled out, I know that my holes for my wall plate are lined up perfectly, and these are 2 that need to be lined up just right. Next I will use the 1/8 inch drill bit to do all of the 8 outside screw holes, the 36 holes for each cue, and for the power connections, the LED, key switch, and the stylus. So I'll start those all with a 1/8 inch drill bit. Okay, so I drilled a 1/8 inch pilot hole for all of the holes on my template. The next thing I want to do is I want to open up all of the holes with the exception of the LED hole and the key switch hole, which are both going to be 1/2 inch holes. I want to open up all the other ones with a 1/4 inch drill. I'm going to do those right now. Also, just a word of advice: when you're drilling through this thin fiberboard, try not to push too hard. Let the drill do the work for you. Let the drill bit do the work for you. This stuff is very thin, very easy to break. It's nice and solid when it's one solid piece, but if you push too hard, you can get cracking and peeling like we did in this one corner. Now all the holes have been reamed out to 1/4 inch, with the exception of the hole for the LED light and the hole for the key switch. We're going to open those up with a 1/2 inch drill bit. We're also going to make a hole in this opening right here for the switch plate, the Cat 5 plate that's going to go into there. If you notice on the Cat 5 plate, there's a little bit of a recess right here where the 6 Cat 5 connections actually come through. If we didn't make a recess for them, first of all, we wouldn't be able to get our Cat 5 connectors through the board. The other thing is this panel would sit above the board. So I'm going to start one hole in one corner so that I can use my jigsaw to open that hole up. Okay, so I've drilled all 3 larger 1/2 inch holes. Next step is going to be to take our jigsaw and to cut the gray area out of this portion here. Okay, and I've cut out the hole in the middle of where my switch plate is going to go. And you notice the switch plate drops right into place. It's a little bit wider than it needs to be, but that's fine. It'll be covered up by the plate itself. And the next step is going to be to carefully remove our paper template. And we're going to put our template to the side in case we need to reference it later, or we could actually just print out another one of the templates to reference it. And we'll take our plate that we just made, and we could either use the 1/8 inch bit, 1/4 inch bit on the drill and clean up all the holes, or we could use a piece of sandpaper or even a razor knife if we wanted to just make sure that we clear out all the holes and openings so that all of our devices will fit through them. Okay, so let me do that next. Now that you've cleaned everything up, you want to test fit some of the parts that are going to be going through your panel. For example, I test fit one of the LED light through the proper hole that it's going to be going through. I test fit the key switch through the hole it's going through. I also test fit one of the screws through a couple of the different openings for the actual cues themselves. I also test fit one of the banana plugs in one of the holes and found that it was a little bit tight, so I opened it up with a slightly larger drill bit. And the next step is to take this panel and paint it. Now that we're satisfied with the hole sizes, and give it a little bit of a cleanup. So I'll go outside and I'll spray paint this with some nice white spray paint. You can paint it, of course, any color that you'd like to. I just find that white works the best. You could use a black tip marker on it and write whatever you'd like on it, and you get a good contrast. But use whatever you'd like. I'm going to paint this up right now. Okay, now here's our panel after a couple of coats of spray paint, and allowed the paint to dry. The next step is going to be to put in the LED light or power light. Once everything's measured out properly, it's pretty straightforward. Just get it into place. This particular unit comes from Radio Shack, and it's a push-in style light. And then we'll put in our on-off keyed switch. So I'll put that onto the plate as well. This particular one, I know that if I put it in this position with the key at the 6 and you see the little tabs at the 6 and 9 o'clock position, I know that if I put the key in at the 6 o'clock position, it'll be off. When I turn it to the right, it'll turn the unit on. So I'll put this in. And attach the nut to the back of it. For the sake of time, let me also show you the banana plugs that I'm going to be putting into place. Essentially, there are 3 parts to them. The body, little tab with for an electrical connection, and a nut to hold them in place. First, we start by putting the 3 different bodies through. Now I put 3 banana plugs into the panel, 2 at the top for power connections. I like to go with 1 red and 1 black so we have a positive and negative connection showing, and 1 at the bottom for the stylus. The color of this one really doesn't matter. In most of the kits that you get on our website, I believe they'll be mostly red, but it really doesn't matter. It's just a matter of choice, which you prefer. On the back, to complete these connections, we'll put the little washer style tab on, and we'll screw a nut over top of it, and we can actually lift this tab out of place a little bit, bend it up a little bit, so that we can make our electrical connections to that tab when we're ready to make them. Okay, so we do that for all three of these units, and we tighten them down. Okay, and after tightening them, that's what all of the connections look like. So we've got our 2 power connections, our LED light, our keyed switch, and a banana plug for our stylus, which we'll be using to set everything off. We're going to jump ahead a couple of steps from the guide, and I'm going to install the Cat 5 panel or switch panel. It's pretty simple. Just put it into place, line up the holes for the bolts, drop the bolts through, and tighten them in the back. And like I said, we did jump ahead a few steps, but that's it. The Cat 5 connections are ready to go, and depending on what plate type you buy, you might need to get matching nuts for the bolts that come with your switch plate, your Cat 5 switch plate. So the next step is to put in all of the screws for each of the cues. So let's take a look at how we're assembling those. Okay, so the last thing to connect to our board are all of our 36 pins, the actual pins that we're going to fire off our pyrotechnic devices from. So simply put, those pins are made out of 3 items. A machine screw, number 8-32 by 1/2 inch long. A nut for that screw, also number 8-32 nut, and a ring terminal clip. And we're going to make our 36 pins by taking our screw, putting it through the board, and then on the back of the board, once we put the screw through the board, we would put our ring terminal through. We put the screw through our ring terminal, and then we would connect our nut to the end of that to hold it in place and to complete the connection. Now, you can put all of these in right now if you'd like to, depending on how you'd like to complete the next step. Personally, the next step I like to do in a little bit different of an order. We need to connect a wire to each one of the 36 ring terminals. So, what I'm going to do is I'm going to put in all 36 screws first, and then we'll move on to our next step. Okay, so all of our bolts are in place. You can see that from the front and from the back as well. The next step is going to be labeling each of the cues and each of the banks of cues. Okay, so I personally like to letter the banks of cues, so I'm going to make each column a bank, A, through F, and I'm going to make each cue a number. Now you can do this any which way you want to, really, as long as you're consistent in how you're labeling your cues and how you're wiring them. I'm also going to label the banks on the Cat5 faceplate. And with those, once again, it's the same thing. As long as you're consistent, it doesn't matter how you label them, as long as you label and wire them the same. If we flip the unit over, you're going to want to label them the same way. So the columns are going to be labeled backwards. Cues are going to be labeled the same numerically. And so we went A, B. So A is over here, B. Putting labels on the back really will help you a lot later on when you start wiring everything up. You'll see within the next steps how that's going to help. Okay, our next few steps of wiring are going to involve working with female Cat5 connectors. These will snap into the faceplate that we put on the front of our board, and they're labeled for, take a close look there, they're labeled for wire positions. And we'll also be working with some Cat5 cabling. If you're going to get some from your local hardware store, try to make sure that you get pieces that are made out of copper, full copper. A electrical multi-use tool. This one's a wire stripper and cutter and crimper all in one. And a multimeter. We'll get into how to use the multimeter in a little bit. Let's first start by taking a look at our Cat5 connector. If we take a really close look at it, you can see numbers on the side corresponding to each opening. And you see 1, 2, 3, and 6 on that side with color codings on them. The color codings, or key, see on the side it's 4, 5, 8, 7. The color codings are to correspond with the wire colors that you will see on the Cat5 cables. Okay, so let me open up the Cat5 cables and we'll take a look at that. Now I took a piece of Cat5 cable, about 1 to 2 feet long, and I took some of the jacket off of either end. You can see the wires that are exposed. You'll see pairs of wires, and they're color coordinated, or color coded, I should say. Orange and white with an orange stripe, brown and brown with a white with a brown stripe, green and white with a green stripe, and blue and white with a blue stripe. Now what we do next, depending on how your Cat5 connectors are made and how the manufacturer states that you're supposed to connect them, our next job is to connect these to their corresponding spots in the Cat5 connector. You'll see there's an A and a B spot for the coding of the wires. It doesn't matter which one you go with as long as you're consistent throughout your whole project. I usually go with the ones that are labeled A, and I do that throughout the entire project just so I don't make any mistakes. Okay, so if you look under spot 1, we need white with a green stripe. That's what that green, the white stripe is through it. 2 is just regular green. So let's get the green and the white with the green stripe first. and according to the directions on the box, you're supposed to just take them, slide them into place. Oh, put that one in the wrong spot, you see? So solid green goes into the second spot. White with a green stripe goes into the first spot. Now I'm going to, good push. Now I'm going to complete that with all of the other wires. Okay, so I've got all the wires into the correct corresponding color-coded spots. According to the manufacturer of this Cat 5 connector, the next step is to take this little cap that they provide with it. You see these little ridges that are in it. Line it up and push it down into place, and that'll help to make the wire connections within this Cat 5 connector. If you have any wire that's hanging over the edge and you want to clean it up, now's the time to snip it back a little bit. And once you're done with that, the next step would be to take the other end of your wires and using your wire stripping tool, strip a couple of inches off of each end. And you can see this is a nice quality copper wire underneath. Okay, so do that for the other 7 wires that are on the other end. And our next step is going to be to test all the connections that we just made. We want to test these before we go any further to make sure that all of these connections inside of this Cat 5 body are correct. So we're going to use our multimeter tool. You might have a multimeter that has what they call a continuity tester. This particular one does not have one, or at least I couldn't find it, so I put this into diode mode. And with it in diode mode, if you take a close look, there's an open circuit. You'll see that it's got a 1 on the dial. Once the circuit is closed, it'll start reading some form of resistance. So in order to test our new Cat 5 connections, we'll be using a 100-foot Cat 5 cable with male ends at either end, along with one of our Castle Pyro breakout boards. I'll take the Cat 5 cable, the 100-foot Cat 5 cable, connect one end to our breakout board, and I'll connect the other end to the female Cat 5 connection we just made. Now, if we take a look at our connections, spot number 1 is going to be white with a green stripe. So, if I go to my cord that's white with a green stripe, connect one end of my multimeter to it, take the other end and touch the positive side of my breakout board for igniter 1 or position 1, you could see that it's showing a connection. So let go, it goes back down to 1. So I touch it, we're going to 016, 015, which is showing the resistance over the wire. I'm going to try that with each of the positions, 1 through 6. So number 2 is solid green. That would go to the number 2 spot on the board. Connection here. There we go. And all the way up through 6. Now for 7 and 8, which with the color coding that we're using is white with a brown stripe and solid brown, we're using both of those for our ground connections. So either one of those will show a closed circuit with any of the negative or ground positions on our Castle Pyro board, our Castle Pyro breakout board. Okay, so that's with position 7 and 8. In this example, it's white with a brown stripe and solid brown. Now, if you weren't going to use the Castle Pyro breakout board, you could do the same test just by taking a regular Cat 5 cable, another 100-foot Cat 5 cable, and clipping the male end off of one end, stripping a little bit of the wire jacket off, and labeling each position. Okay, so we have our two brown and white with the brown stripe is ground, and then A6 all the way down. Make sure that you're labeling these the same as the positions that you have on your female Cat 5 cable, and you do the same test. You would just test from this end to this end, make sure that they're matched up. If they're not matched up, or you're finding a circuit is not showing as closed and it stays at 1 or it stays at open, if you're using a continuity tester on your multimeter, then you want to start checking your connections at your female Cat 5 cable. Since our connections are all good, we're going to move on to our next step. And our next step in this process would be to connect our Cat 5 cable to our board, and then start making the connections between these cables and the associated pin on the board itself. Just a little side note, personally I like to take each Cat 5 connector and put a little bit of electrical tape around it before I put it into place. It's just in case anything comes in contact with any of those ends, this will keep that from happening. Okay, so the next step is to take each of these connections, except for position 7 and 8, and connect each one of these to a ring terminal. Okay, for now I'll take position 7 and 8, twist them together, and put them off to the side. Okay, let's start. I'll start by taking one of the ring terminals and taking the actual terminal part from the jacket that goes on it. I'll take the wire that I'm going to connect to the terminal, ring terminal, and give it a little bit of a twist to keep all the wires nice and bunched up together. Slide it through the plastic collar. Next step is to take the ring terminal itself, and I like to thread the wire through that opening on the ring terminal. Bring it up and through, and give it a little bit of a twist. You can see it's making good contact all the way through that hole. Next step is to get the collar back onto the ring terminal itself. Then after that's done, I'm going to crimp the ring terminal itself. Now you might want to put a little bit of solder in there if you really want to go all out. Personally, I think this is enough, and solder might be a little bit of overkill, but that's entirely up to you. I'm going to do the same thing with the rest of the wires, numbered 2 through 6. Okay, so we've made all of the connections for each of our wires, except of course for our 2 ground wires, which are the white with brown stripe and the brown, or positions 7 and 8. So the first thing we need to do is take the wire for position 1, which in this case is white with a green stripe. And if you have problems remembering, you could always check on your female Cat 5 cable or another one that's not in use at the time. We're going to put position 1 right here, since this is bank A, and that's Q, or position 1. We'll put it on on position A1. And I'm going to do the same thing with all the other ones. I'm going to check to see what number they are, put them on, and then I'll tighten each one down. Okay, And that's all 6 connections for our A bank. Next step is going to be to test to make sure we're getting a good connection on all of those. And we're going to do it the same way we did before. Plug Cat5, 100-foot Cat5 cable into the front of the panel. The other end is going to plug into our breakout board. Now once again, if you're not going to use the breakout boards, you can use the Cat5 cable, the male end on one end and the other end with stripped and labeled cables on it. Set my tester at into diode mode, and the same thing once again. It's a little bit easier this time because you don't have to worry about which colors are supposed to be connected to which Q. So A1, test on the positive side. A2, go to igniter 2 on the positive side, and all the way down. Now I'm going to repeat this process for each of the 6 banks. For this demonstration, I'm not going to complete that because it would just take too long and be way too repetitive. So, if you're making one at home, you would do this process of connecting a Cat5 connector to a piece of cabling and connecting it to each of the Qs. You're going to do that for each of the banks and each of the Qs, making sure you line them all up, and then we'll move on to our next step. Our next few steps are going to focus on the connections of the keyed switch, the LED light, our battery terminal connections, and our stylus connection. So we're going to start by taking the keyed switch and cutting the connector off of the end. We'll be using just the bare wires. And we're going to take each of these wires and strip them a little bit to show a little bit of the wiring underneath so we can work with it. We'll do the same thing for the LED. Strip a little bit of wiring underneath it. Okay, so I stripped the wire ends on my LED and my keyed switch. The one other thing which I forgot to do before was label my positive and negative connections for the power connectors for the banana plugs. I'll do that actually on both sides, on the front and the back, just so there's no confusion, and also the bottom plug for the stylus. The other thing which I've already done was take a short piece of wire, something at least 20 gauge or thicker, and strip either end, and this is going to be the lead from our negative connection. It's going to connect to all of our negative connections on the system. So I'm going to loop a piece of wire into there. I'm going to take one of the lead wires from the keyed switch and put it into the positive connector. I'm sorry, into the positive banana plug. Give it a little twist, and I'll come back and solder those into place in a few moments. I'll take the negative wire, which I just connected one end to the negative banana plug. I'll connect the other end to one of the leads going into our LED light. And also we'll take all of our bundled up negative connections for our Cat5 connectors. In this case we just have one, but once we have all 6 I would take them all and twist them all together. And I will twist all of these together in order to be soldered to one another. Okay. Obviously once we get all of the other Cat5 connections in, there'll be another 10 wires, 2 for each bank, that are left over, connected to this bundle right here for the negative leads. I'll take the other connection from my LED light. Okay, so one connection's going to negative, the other is going to go to the other end of the keyed switch. I will twist those two together, and I will pass them through the eyelet for the stylus, so that whenever we have power coming into this unit, it'll come in through the power connection, the banana plug power connection, go to the keyed switch. The keyed switch is turned off, it won't be allowed to go anywhere else. The keyed switch is turned on, power will flow both to the stylus and to our armed light to let us know that the system is armed. That's only when the system is turned on and has power connected to it. The negative will always be connected to the negative side of the LED light and to the negative connections on our Cat5 connectors. Okay, so the next step would be to solder up these 1, 2, 3, 4 connections. Now, of course, following all the directions and precautions that come with my soldering gun, I'm going to plug it in, start preheating it. I'm going to use a little soldering flux, and I'm going to apply some to each of the 1, 2, 3, 4 connections that I'm going to be making. Okay. Okay, and once my soldering iron's all nice and warmed up, go ahead and I solder the parts together. Once all of your negative connections have been made together, it's a good idea to wrap them with a little bit of black electrical tape. Okay, so the next step in the process would be to test all of the connections again in your completed box. Okay, so moving forward, I'm going to complete the rest of this video with a completed box to show you every connection, so you get a better idea of how many different connections you're going to have to test. I'm going to start by plugging a cable into a 100-foot Cat5 cable into bank A. On the other end of that cable plugged into one of our breakout boards. Once again, if you're not using our breakout boards, you'd have a Cat5 cable with one end opened and labeled, as we showed you before. Okay, I'm going to take our tester, set it to diode testing. I'm going to take the positive connector from our battery connection. These are the adapters for a battery. And I'm going to take the positive connector and connect it to one end of our multimeter. Okay, and I take the other probe from the multimeter and I'm going to plug it into our field unit's positive connection for position 1, or igniter 1 as it's labeled. I'm going to take our stylus, plug it into our board. Now, just to note, with the key turned off, if we touch the stylus to position A1, nothing will happen. Multimeter stays at 1, and I'm going to turn the unit into the on position. The armed light will not turn on because there's no power actually going through the unit. And when I touch the stylus to position A1, I'm going to complete the circuit, and you notice our multimeter has changed. I'm going to run this test for every single position of bank A. So position 1 through 6, I'm going to change the one side of the multimeter to the next position, check A2, and so on, all the way up through. Next, I'm going to take the one probe from the multimeter and disconnect it from the positive side of the battery connection. I'll connect it to the negative side of the battery connection. I'm going to take the other side of the multimeter and I'm going to test each of the negative connections for bank A. Doesn't matter if the unit is turned on or off. Remember, our negative connection does not depend on the keyed switch. So you see each of our positions, for each of our negative positions for bank A, show a closed position when connected to the negative lead from the battery. So that means that the negative connection for the battery will go to each of these positions on our field unit breakout board, or to cables 7 and 8 if you're using just a regular opened wire. And each of the positive positions will only have positive electricity flowing through them when the system is turned on and when the stylus touches the correct cue. You're going to do the same test for each of the banks. So you can do it for every position in bank A and then every position in bank C, D, E, and F. It might seem tedious, but it's a lot easier to test them now in the comfort of your own home or shop or wherever you're working, rather than to find out when you're setting up a show that one of your positions is not working properly. And I know I've tested a lot in this video and it seems like it's test, 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 but once again, it's a lot easier to test now than it is to find something broken and to be disappointed when you're trying to fire a nice fireworks show. So, with all of our testing completed, we can take the board out of the unit rather, and seal up the back of it with some silicone sealant. I like to cover each and every one of the pins just to make sure there isn't a chance for an accidental short circuit. And then after I allow it to dry, according to the manufacturer's suggested drying time, I'll take the board and put it back into the box, screw it back into place, and we're all set and ready to go. Your firing system is complete, and now let's see the proper way to use it. Okay, so we're ready to use our unit. We'll be using this unit with consumer type igniters. If you take a look at these igniters, it might be difficult to see in this video, but inside that clip there's a little piece of bridge wire or nichrome wire. The idea is to take this clip and put your fuse inside that opening right there. So you slide your fuse in, you clip it down, and that little piece of bridge wire is going to go around your fuse. The other end of this igniter has two pieces of copper wire on it. Take those. I personally like to just double them over. And since we'll be using our field breakout board, we can connect them like so. Give it a little push. And I'm going to connect one end to our Cat5 cable. Normally, obviously, this will be stretched all the way out to wherever you want the device to fire off. Before you connect this to this unit, I'd suggest taking the key out and making sure that there's nobody out in the field that you're about to fire these fireworks off in. Make sure everything's all clear. I would hold the key with you when the firing unit's not being used, because there is always a chance of electrostatic discharge once you connect these igniters to the fuse. Okay, so for this demonstration I'm going to actually take the top off of this igniter just to show how it works a little bit better. Now if I wanted to test my connectivity to this igniter, I can take my positive and negative leads to my firing system, connect them to my multimeter, turn it on. There's also a danger of setting off the igniters when you do this, depending on how much power is actually running from this unit to the actual cue itself. I touch this to QA1. You notice nothing happens. Once the system is turned on, you'll see it's making a connection. So that's a closed circuit. Let's turn it off. And there you go. Okay, so next, once I'm sure that everything is all clear, I can connect to my power source. For this example, I'm just going to use a regular 9-volt battery. Connect negative to negative and positive to positive. Okay, and in this case, like so, whatever power you'll be using for your system. And I know that with the LED that I've used for the system, a 9-volt battery will be sufficient to show that the system is armed and ready to go once it's turned on. Okay, so we're all set. And once we're ready, we can fire this cue by touching our stylus, which is connected to the stylus connection, to cue A1. That's it, and that would fire off our fireworks or our pyrotechnic device. Once you're done with firing a show, once you fired off all your igniters, make sure to turn your system off, unplug your battery, unplug your stylus, and before you go to do anything in the out in the field with the pyrotechnic devices, I would suggest disconnecting all of your Cat 5 cables for two reasons. The first is if there's anything that's not been fired off, you wouldn't want to have the chance of it being accidentally fired off. The other reason is because as people walk through the field, or as personnel walk through the field, if they pull on these Cat 5 cables, they can pull your box over and possibly break it. Just a little side note, if you have a two-keyed system, you might want to keep the spare key somewhere safe, just to be sure that you have it in case you're ready to fire a show and you lose your key. And that's pretty much it. There's a couple things that you can do to make this system a little bit safer, a little bit more robust. One thing is you could always put a fuse in line with the power connection. So that'd be from the wire that's coming from this power connector going to the keyed switch. You can put a fuse in line there in case you want to protect the system from any accidental shorts or misfires. It also helped to keep you from excessive voltage from burning out any of your wires in case any of your igniters are bridged, or in case anyone accidentally connects. If you're using the open-end wiring system, anyone connects two of them together that shouldn't be. And I'd also suggest when you're not using the unit, keeping it closed and sealed. These cases are great. They're pretty bulletproof. Not really bulletproof, but you know, you could drop them pretty far without hurting the contents inside. If you take good care of your firing system, it'll last you a long time. And if you'd like any more information on parts, or if you have any questions, please go to our page, castlepyro.com. We have kits that'll help you build this system, including most of the off-the-shelf parts that you won't normally get, like the styluses and these banana plugs and the keyed switch. We also offer, of course, our breakout boards and Cat 5 cabling, quality Cat 5 cabling. But please feel free to contact us if you have any ideas or if you have any questions. Thank you for watching.